Again we are defining some variables. What those variables are? Again related to something we will use later. Okay, like here communication range variable we defined here but used here in this equation. Similarly these values we are defining here but we will use these later. Okay, now let us understand quickly. This variable is value of channel means value of channel is what? Channel oblique wireless channel. Value of propagation is what? Propagation oblique Nakagami. Value of start is what? 10. Value of net is what? Physical layer wireless PH by EHD. These things, some variables are defined here and their values are given here. So value of MAC is what? MAC oblique 802.11 EHD. IFQ means Q is what type of Q we are using? Q oblique DSRC. LL is what? LL means link layer is same. Antenna type, value of ANT means value of antenna is what? Omnidirectional antenna. Value of X is what? 5000 means X dimension of the topography. Value of Y is what? 20, Y dimension of the topography. Interframe Q, IFQ length means what is the length of the queue? 20 means how many packets can be stored in a particular queue of node? 20. Value of NN means number of nodes is there. How many? Value of N cars what we used here. Value of RTG means routing protocol, we are using AODB. Value of stop we are using 150. These things are provided. Means we have defined some variables here. Now we will use it later. How we will use it? We will see. Now from this line to this line, you don't have to do anything. You just have to copy and paste it in every TCL file of your vehicular network. Why? Because these are some physical layer properties. Okay, some physical layer properties or MAC layer properties are available, means are provided here. Propagation model properties. So these things you should not change unless you are working on physical layer. Okay. So since we are working on MAC layer, so we won't be changing these things. However, some parameters here from here to here are related to MAC layer. Okay, here it is written MAC. So these things I will tell you but not now because these are redundant. You just have to copy and paste these things every time. Okay. So I am skipping these lines. Now here the main actual program begins here. By now we have only defined some variables. Okay. We have not defined any simulator object or anything yet. So what we have to do? Set ns underscore new simulator. And ns underscore is what? A variable. New simulator, it is a command. So ns underscore will point towards a simulator object. Means one simulator environment is created. It is as simple as that. Topo is a variable, new topography. New topology will be created in this variable topo. Now, one thing is there. I told you two output files are there when we run any TCL file. First one is trace file, another one is name file, network animator file. So how to develop, how to generate those files? These 4 lines do the work. Set trace FD. Trace FD is what? The variable name. What this variable represents? A file that is opened in the write mode and it has the name this one, IEEE 802.11p.tr. Okay. This file is opened in write mode. So this variable points toward that file. Now ns underscore trace all. what is this ns underscore? This simulator object what we have created. So whatever simulation will be there, everything will be traced. Trace all, this is also a command. Trace all, we cannot change this command. Everything will be traced into trace fd. What is trace fd? Trace fd is this variable. And this variable represents what? A file named IEEE 802.11p.tr in write mode. So we can write a file named this using this command. Okay, so every event will be written in this file using this variable. Okay, it is very simple. You just have to copy and paste it in every program. ns underscore use new trace. This command you have to give always. Always you have to provide this command ns use new trace. You can comment it also, but if you comment it, the awk file that I have provided you will not work if you comment it, because it will be, the trace file format will be different. Okay, so you should provide this command always if you want to use the awk file that I have provided. Now set name trace. These two lines I have written here, the same lines are repeated. The only difference is the change in variable name and the file name. Okay, set name trace, this is a variable name. Open name file.name in write mode. In write mode we are opening name file.name. So what will happen? ns underscore name trace all wireless. So this is also a command. Like this was the command for tracing the trace file. This is the command for tracing the network animator file. So every event will be written in name trace. What is the name trace? This variable, and what this variable is showing? This file. Okay, so every event will be traced in the name file.name. Every event is being traced here also as well in trace file and in name file as well, but the format of both are different. Why? Because network animator file is fed into the network animator software. Okay, and this trace file is used with AWK. Okay, after here we are providing value of x and value of y, the length size of our topology. What was the value of x and value of y? Here you can see value of x we provided as 5000 and value of y we provided as 20. It is in meters. So our scenario is of 5000 cross 20 meters, means 5000 meters by 20 meters. Okay, so up to here, okay. So these lines will generate two files. First file will be named as this one, IEEE 802.11p.tr. You can change the name of this file, okay, whatever you want, and you can change the name of this file as well.